Ever catch yourself scrolling through a news feed and think, wait, how did they get that from these
Yeah,
numbers?
like what's the story here?
Exactly. That's the exciting world of statistics we're diving into today. Specifically, the AP Statistics curriculum.
And we're not just talking like dry textbooks.
Right.
We've snagged the College Board's draft revised course framework.
Ooh, exciting.
Yeah, which is basically the roadmap for how to think statistically.
Okay, so map this out for us. What's the big picture? What kind of terrain are we covering?
Okay, so imagine 5 units,
Okay.
starting with single variable data.
Okay, so that's like Stats 101.
Exactly. But then we climb all the way to regression analysis.
Now, I gotta be honest, regression analysis, that sounds a little intimidating. What does that even mean in plain English?
So think of it like this. Let's say you're trying to predict how many scoops of ice cream people will buy depending on the temperature outside.
So,
Regression analysis helps you figure out if there's a relationship there, and even lets you make predictions about future ice cream consumption based on the weather forecasts.
okay, that makes sense and definitely sounds tastier than regression analysis. But before we start predicting ice cream sales, let's back up a bit. What are some of the key skills and concepts outlined in this framework? It can't just be about memorizing formulas, right?
You're absolutely right. AP Stats isn't about rote memorization. It's about developing a statistician's toolkit.
Love it.
And that starts with 4 key practices: formulating questions,
Okay.
collecting data,
Uh-huh.
analyzing that data,
Okay.
and then interpreting what you found.
So it's like being a data detective.
But even detectives need the right tools to crack a case. What kind of tools are we talking about in the world of AP statistics?
Just like a detective might dust for fingerprints or analyze DNA evidence.
Right.
You'll be using a bunch of graphical tools, visual representations.
Okay.
Think histograms, box plots, the works.
Yeah.
These help you unlock the secrets hidden within the data.
So we're talking about going beyond just looking at raw numbers in a spreadsheet.
Exactly. Imagine you're trying to compare the heights of basketball players and jockeys.
Okay.
Just looking at the raw numbers might not tell you much, but plot those heights on a graph, and suddenly the differences jump out at you.
Right. Okay. Visuals definitely make things clearer. But what about those tools that help us make sense of the numbers themselves? What are some of the key concepts we'll be using? Well, you've got your measures of center, like the mean and median, which tell you where the typical value lies.
Right.
But then you've also got measures of variability, like range and standard deviation.
Okay.
Those tell you how spread out the data is.
So if we stick with our basketball player and jockey example, the range and standard deviation would show us how much variation there is in height within each group.
Exactly. A large standard deviation means the heights within that group are more spread out, while a small standard deviation tells us the heights are clustered closer together.
That's a great way to think about it. It's like comparing the heights of all the players on a basketball team versus the heights of everyone at a family reunion. You'd expect to see more variation in height at the family reunion, right?
Precisely. And speaking of variations, another key concept you'll explore is z-scores.
Okay, z-scores. Now, those always sounded a little mysterious to me. What is a z-score and why should we care about them?
Imagine you want to compare how well you did on a test relative to the rest of your class.
Yeah.
A z-score tells you exactly that. It's a measure of how far away a particular data point is from the mean, measured in terms of standard deviations.
So if I have a z-score of 2 on a test, does that mean I scored 2 standard deviations above the average?
Exactly. It's a way of standardizing scores so you can compare them even if the tests were graded on different scales.
Okay, that makes a lot of sense. But z-scores aren't just for comparing test scores, are they?
Not at all. Z-scores are used in tons of different fields. Imagine you're a doctor monitoring a patient's blood pressure. Z-scores can help you determine if their blood pressure is significantly higher or lower than the average for people their age and gender.
Wow, so z-scores are like the secret sauce for comparing data that might seem totally unrelated at first glance.
You got it. They're a powerful tool for uncovering patterns and making sense of data in a standardized way.
This is already blowing my mind, and we're just getting started.
And believe me, it gets even more exciting as we move into probability and start talking about things like random processes and the law of large numbers.
Speaking of probability, that's another area where people throw around terms without always understanding what they really mean. What exactly are we talking about when we talk about probability in statistics?
It's all about quantifying uncertainty. We use probability to describe the likelihood of different outcomes occurring in the face of randomness.
So like flipping a coin. There's always a 50-50 chance of getting heads or tails.
Exactly. That's probability in action. And in AP statistics, you'll dive much deeper, exploring concepts like conditional probability, which is the probability of an event happening given that another event has already occurred.
Ooh, that sounds intriguing.
Yeah.
Can you give us a real-life example of conditional probability?
Sure. Let's say you're looking at the probability of someone having a certain disease given that they tested positive for it.
Okay.
That's conditional probability, the probability of having the disease given a positive test result.
Okay, so it's not just about looking at the probability of having the disease in general, but taking into account additional information like a positive test result.
Precisely. Conditional probability helps us make more accurate assessments of likelihood in situations where we have additional information to consider.
This is already making me think about all the data I encounter every day in a whole new light.
And that's just the tip of the iceberg. As we move further into the curriculum, you'll explore even more complex concepts like sampling distributions and statistical inference.
Sampling distributions. Now, those sound pretty important. What exactly are we talking about there?
Imagine you're trying to estimate the average height of all students in a school, but you can't measure every single student.
Right.
So you take a random sample of, say, 100 students and calculate their average height. That average height you calculated is one data point in the sampling distribution of the mean.
So the sampling distribution represents all the possible sample means we could get if we kept taking different random samples from the same population.
Exactly. And understanding the shape, center, and spread of sampling distributions is crucial for making inferences about the population from our sample data.
Inferences about the population.
Yeah.
Okay, now you're talking about some next-level statistical superpowers. What exactly does that mean?
Imagine you're a market researcher and you want to know what percentage of people in a city prefer a certain brand of coffee. You can't ask every single person in the city, right?
Right.
So you take a random sample and use that sample data to make an educated guess or inference about the preferences of the entire population.
So it's like using our sample data as a crystal ball to predict what's going on in the larger population. That's pretty powerful stuff.
It is powerful, but like any powerful tool, it's important to know how to use it correctly.
Yeah.
That's where statistical inference comes in. It provides a framework for making these inferences in a rigorous and reliable way.
I'm starting to see why understanding this stuff is so important. It's not just about numbers on a page. It's about using those numbers to understand the world around us.
Absolutely, and that's just the beginning. In the next unit, we'll dive even deeper into inferential statistics, exploring concepts like confidence intervals and hypothesis testing.
Confidence intervals and hypothesis testing. Those sound like powerful tools for a data detective. Can't wait to learn more about them.
And those tools are essential for going beyond just describing data. They let you test theories and make decisions based on evidence.
Okay, so walk us through this. How do confidence intervals and hypothesis testing fit into the picture? They sound kind of like courtroom drama terms.
Well, you're not far off.
Okay.
Imagine you're trying to estimate the average height of all students in a school again. A confidence interval would be like saying, we're 95% confident that the average height falls between, say, 5 feet 2 inches and 5 feet 6 inches.
Okay.
It gives you a range within which you're fairly certain the true population parameter lies.
So it's like saying we can't know the exact average height of every student without measuring them all,
Right.
but we're pretty darn sure it falls within this range.
You got it.
Okay.
And hypothesis testing is where the courtroom drama really kicks in.
Okay.
Let's say you have a hunch or a hypothesis that students who drink coffee before a test perform better.
Right.
Hypothesis testing helps you determine if there's enough evidence in your data to support that claim.
So we're gathering evidence like good data detectives to see if our hypothesis holds up in court, statistically speaking. But there are so many different statistical tests out there. How do we know which one to use? It's like having a whole toolbox full of gadgets and not knowing which one to grab.
That's a great analogy.
Yeah.
And just like a good mechanic knows which tool to use for each job, understanding when to use which statistical test is crucial. For instance, you might use a chi-square test when dealing with categorical data, like trying to see if there's a relationship between favorite ice cream flavor and personality type.
So if I have a theory that people who love chocolate ice cream are more likely to be introverts, I'd use a chi-square test to see if the data backs me up.
Exactly. And on the flip side, if you're working with quantitative data, like comparing the average heights of two groups, you might use a t-test to see if the difference is statistically significant.
Okay, so we've got chi-squared tests for categorical data and t-tests for quantitative data. But remember how we talked about regression analysis earlier with the ice cream sales and temperature example?
Right.
Where does that fit into all this?
Good memory. Regression analysis is a whole other level of statistical detective work. It's not just about seeing if there's a relationship between two variables, but about quantifying that relationship.
So instead of just saying hotter weather seems to equal more ice cream sales,
hmm
we can actually use regression analysis to say, for every degree the temperature rises, we can expect ice cream sales to increase by X amount.
Precisely. And that's incredibly valuable for making predictions and understanding how changes in one variable might affect another.
This is really making me realize how much statistics is about uncovering the hidden stories behind the numbers.
hmm
It's like being a data storyteller.
Exactly. And to tell those stories effectively, we need to make sure we're collecting good, reliable data in the first place.
Right, like we said earlier, garbage in, garbage out. If our data is flawed from the beginning, our analysis won't mean much.
Right.
So how do we make sure we're collecting data the right way? It's not just about sending out a bunch of surveys and hoping for the best, is it?
Definitely not. The way we collect data is just as important as how we analyze it. The AP statistics curriculum delves into different sampling methods, highlighting the importance of random sampling to ensure our sample is actually representative of the population we're interested in.
So if I'm doing a survey to see what kind of pizza toppings people prefer, I can't just ask all my friends who love pineapple on pizza.
Exactly. You want to make sure your sample is diverse and represents the larger population you're trying to understand.
Right.
Otherwise, your results might be biased and not reflect what's really going on.
That makes a lot of sense. And I imagine there are other potential sources of bias we need to watch out for, too. Like the way we word our survey questions could influence people's responses, right?
Absolutely. That's why the AP statistics curriculum also emphasizes the importance of identifying and mitigating bias in data collection.
It's all about making sure our data is as accurate and unbiased as possible so that we can draw meaningful conclusions from it.
Precisely. And that brings us to another crucial distinction in the world of statistics: the difference between observational studies and experiments.
Okay, break that down for us. What's the difference? They both involve collecting data, right?
They do, but in an observational study, we're just observing and recording data without interfering. Think of it like being a fly on the wall, just watching how things unfold naturally.
Okay, so if I'm interested in seeing if there's a relationship between how much coffee people drink and how much they sleep, I could just ask them to track their coffee and sleep habits for a week.
Uh-huh.
That would be an observational study.
Exactly. You're not manipulating any variables, just observing and recording. But let's say you wanted to go a step further and see if reducing coffee intake actually causes people to sleep more.
Okay.
That's where experiments come in.
So with an experiment, we're not just observing, we're actively manipulating something to see what happens.
Exactly. You might randomly assign some people to drink less coffee and others to maintain their usual intake, then compare their sleep patterns.
That makes sense. But designing a good experiment sounds tricky. How do we make sure it's actually the coffee reduction that's causing the changes in sleep and not some other hidden factor?
That's where those principles of experimental design we touched upon earlier come in. Random assignment, control groups, blinding.
Right.
These help us minimize bias and isolate the effects of our manipulation.
So with random assignment, we're making sure that the groups are as similar as possible at the start of the experiment so that any differences we see later on are more likely due to the coffee manipulation.
You got it. And by using a control group, a group that doesn't receive the coffee reduction, we have a baseline to compare against.
Okay.
And blinding means keeping either the participants or the researchers or both in the dark about who is receiving which treatment. This helps reduce bias that can creep in if people know which group they're in.
Okay, so it's all about designing experiments that are as airtight as possible.
Yeah.
So we can confidently say, yes, this manipulation caused this outcome, or nope, it seems like there's no real connection there after all.
Precisely. And the AP statistics curriculum gives you the tools and knowledge to not only analyze data, but to design studies that will yield meaningful and trustworthy results.
It's like becoming a master data detective, able to collect clues, analyze evidence, and crack the case wide open.
Exactly. And as you delve deeper into the curriculum, you'll encounter even more sophisticated tools and techniques for analyzing and interpreting data. But no matter how complex the analysis gets, it all comes back to those fundamental statistical practices we talked about earlier: formulating questions, collecting data, analyzing that data, and interpreting the results.
It's about thinking critically about the world around us, asking the right questions, and using data to find answers. It's amazing how much thought and strategy goes into designing studies and collecting reliable data. It's like building a house.
Yeah.
You need a solid foundation to support everything else.
You're exactly right. And just like a well-built house can withstand a storm, a well-designed study can withstand scrutiny and give us confidence in the findings.
Speaking of withstanding scrutiny, I remember hearing about this thing called the central limit theorem.
Right.
It sounds pretty important, but I'll be honest, I'm a little fuzzy on the details.
The central limit theorem, it's like the superhero of statistics. It basically says that even if we have data that's messy and all over the place, the distribution of sample means will start to look like a nice symmetrical bell curve, like a normal distribution, as we take larger and larger samples.
Okay, wait, hold up. So you're telling me that even if my original data is totally chaotic, the more samples I take, the closer the averages of those samples will get to a normal distribution.
Mm-hmm.
That sounds almost too good to be true.
It does sound counterintuitive, but that's the beauty of the central limit theorem.
Okay.
It's a fundamental principle that underpins a lot of statistical inference.
So why is this such a big deal? How does the central limit theorem help us in the real world?
Imagine you're a quality control manager at a factory that produces thousands of light bulbs every day. You can't test every single bulb, right?
Right.
So you take random samples and calculate the average lifespan of the bulbs in each sample. The central limit theorem tells us that even if the lifespan of individual bulbs varies wildly, the distribution of those sample averages will tend toward a normal distribution.
Okay.
This allows us to make reliable inferences about the average lifespan of all the bulbs produced, even though we only tested a small sample.
Wow, that's incredible. It's like having a statistical superpower that lets us make sense of huge amounts of data without having to measure everything individually.
Precisely. The central limit theorem gives us the confidence to use sample data to draw conclusions about entire populations, and that's incredibly powerful.
So we've covered a lot of ground here, from the fundamental principles of statistical thinking to sophisticated techniques like regression analysis and hypothesis testing. But at the end of the day, why should all of this matter to someone who's not planning on becoming a statistician?
That's the million-dollar question, isn't it? And the answer is simple. We live in a data-driven world every day. We're bombarded with information, statistics, in the news, data on social media, research findings in every field imaginable. Understanding the basics of statistics allows you to navigate this information landscape with a critical eye. It empowers you to ask the right questions, identify misleading claims, and make more informed decisions in all aspects of your life.
It's like having a built-in BS detector. Instead of just accepting statistics at face value, we can say, wait a minute, how did they collect that data? What kind of analysis did they do? Is this conclusion really justified?
Exactly. Statistical literacy is becoming increasingly important, not just for academic success, but for navigating the complexities of our world. Whether you're evaluating the claims of a politician, assessing the risks of a medical treatment, or even just trying to make sense of a graph in a news article, understanding statistics gives you a huge advantage.
It's like having a secret decoder ring for understanding the world around us.
Exactly. It allows you to see patterns, make connections, and draw meaningful conclusions from the data that surrounds us. And that's a powerful skill to have in today's world.
So for anyone listening who's feeling overwhelmed by the sheer volume of information out there, remember, the statistics isn't about memorizing formulas. It's about developing a way of thinking, a framework for approaching information with a critical and discerning mind.
It's about asking questions, challenging assumptions, and using data to eliminate the truth. And that's a journey worth taking.
Absolutely. It's about empowering yourself to become a more informed and discerning citizen of the world.
And remember, the world of statistics is full of surprises, fascinating discoveries, and mind-blowing insights waiting to be uncovered.
So embrace your inner data detective, dive into the world of AP statistics, and get ready for an incredible journey of discovery.